If 2016 to the power 4 is equal to 1651817 8335536, what is n? Now 2016 is equal to 9 multiplied by 224. Therefore, 2016 is a multiple of 9. So, all integral powers of 2016 will also be multiples of 9. We know from theory of numbers that any positive integer differs from its sum of digits by a multiple of 9. If you do not know this already, convince yourself by these examples, which is, let us say the number is 17. Then the sum of its digits is 1 plus 7 is equal to 8. So the difference between the number and its sum of digits, that is 17 minus 8, is equal to 9. So the difference between the number and the sum of its digits is a multiple of 9. Or take another example. Let us take the number 321, and then its sum of digits will be 3 plus 2 plus 1 is equal to 6. And the difference between 321 and the sum of its digits, 6, is equal to 315. Now 315 is a multiple of 9 because 315 is equal to 9 into 35. So in both these examples, the proposition bears out. Now, note that this is not a proof of the proposition. We have only taken two stray examples and convinced ourselves that the proposition holds true. If you do not already know how to prove this, look at the end of this problem to get a proof. Now, coming back to the problem in hand, let's take the given number 2016 to the power of 4 is 1651817 n 8335536, and let us call it x. We have already argued that x is a multiple of 9. Further, from proposition 1, x minus sum of the digits of x, that is x minus 1 plus 6 plus 5 plus 1 plus 8 plus 1 plus 7 plus n plus 8 plus 3 plus 3 plus 5 plus 3 plus 6 is a multiple of 9. Note that the quantity in the parenthesis is the sum of the digits of 2016 to the power of 4. Let us denote the quantity in the parenthesis as y. Hence, from proposition 1, x minus y, that is x minus sum of its digits, is a multiple of 9. Since both x and y are multiples of 9, it follows that y is a multiple of 9. Why? Let x be 9p and x minus y is 9q, where both p and q are positive integers and p is greater than q because x is greater than x minus y. Therefore, from this equation, y is equal to x minus 9q, or x being 9p, we get y is equal to 9p minus 9q, that is 9 multiplied by p minus q. Let us call p minus q as r so that r is another integer, so we get y is equal to qr. So we conclude that y is a multiple of 9. When we add the digits, y is equal to 1 plus 6 plus 5 plus 1 plus 8 plus 1 plus 7 plus 9 plus 8 plus 3 plus 3 plus 5 plus 3 plus 6, we get 57 plus n. For 57 plus n to be a multiple of 9, we must have n is equal to 6, so that 57 plus n is equal to 63, which is a multiple of 9. So the answer is n is equal to 6. Note that n being a digit between 0 and 9, no other value of n would qualify. Before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later. And if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. I had promised that I would give a proof of proposition 1, that is, any positive integer differs from its sum of digits by a multiple of 9. Now, any integer can be written as ak, ak minus 1, ak minus 2, like this, a1 and a0, where the digits are a0, a1, ak minus 2, ak minus 1, ak. And this can be written as n is equal to ak multiplied by 10 to the power of k plus ak minus 1 multiplied by 10 to the power of k minus 1, so on and so forth until a1 10 raised to the power of 1 plus a0 10 raised to the power of 0, where the sum of the digits of n are s, and let us call it, is equal to ak plus ak1 plus ak minus 2 plus dot 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 plus a1 plus a0. Therefore, n minus Sn, that is the number minus the sum of its digits, is equal to, from this and this, if you subtract the two, we will get ak multiplied by 10 to the power of k minus 1 plus ak minus 1 multiplied by a to the power of k minus 1 minus 1 plus a k minus 2 multiplied by a to the power of k minus 2 minus 1. Like this it will go on. Finally, a1 multiplied by a to the power of 10 to the power of 1 minus 1 plus a0 multiplied by 10 to the power of 0 minus 1, and that is equal to a to the power ak to multiplied by 10 to the power of k minus 1 plus ak minus 1 multiplied by a to the power of k minus 1 minus 1. Like this it will go on. Finally, plus a1 multiplied by 9 plus a0 multiplied by 0. Why that is so? Because 10 to the power of 0 is equal to 1 and 1 minus 1 is 0. Let us call it equation 1. Appreciate the fact that when k is any positive integer, 10 to the power of k minus 1 is a multiple of 9. For example, if k is equal to 4, then 10 to the power of k minus 1 is equal to 10,000 minus 1, and that is equal to 9,999. If k is equal to 2, then 10 to the power of 2 minus 1 is 99, and so on. So in each case, 10 to the power of k minus 1 is a multiple of 9. So From equation 1 above, n minus Sn, that is sum of many terms, each of which is a multiple of 9. Therefore, n minus Sn is equal to a multiple of 9 itself. So proposition 1 is proved. Thank you.